welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about compound interest. Luckily for you folks at home, we've got a very special guest for you. He's the finance phenomenon. People's interest in him compounds weekly. He's the ninth wonder of the world. He's Jay Cho.
Thank you.
Hey Jay, how's it going?
Pretty good, not bad. I just met up with my financial advisor.
Oh really? Why did you meet with a financial advisor?
You know, I just want to check up on my retirement savings. You started your retirement savings too, right?
No. I mean, I'm only 45. I don't plan to retire for another 20 years, so...
What? You haven't started yet? Have you not heard of the ancient proverb? The best time to save for your retirement was 20 years ago. The second best time is today.
No, I haven't heard that one before. So, where did you get this quote anyways?
On Instagram, obviously.
You know, Jay, you can't believe everything you read on social media. Anyways, why is it so important for us to start saving for our retirement early?
Because of the power of compound interest.
Power of compound interest? You know, I was just on Instagram the other day and I saw a whole bunch of Einstein quotes on compound interest.
Well, you can't believe everything you see on social media, Roger.
Let me find these quotes and then you can tell me if you think it's believable or not.
That's wise.
Yep, very deep. Here's another one.
Compound interest is extremely powerful.
Powerful. Here's another one.
Well, I'm not arguing that it's lit, but is it really the greatest mathematical discovery of all time?
Greatest of all time. That's high praise indeed.
Indeed.
Einstein clearly loves compound interest. Maybe you could explain compound interest to our viewers.
Sure, but let's review our simple interest first.
Oh, why would we review simple interest? Are they related?
They are related. If you understand simple interest really well, we should be able to appreciate the compound interest better.
Okay.
Remind us, what are 3 things we need to calculate simple interest?
Well, first we need the principal P, which is the amount you borrow.
Okay.
Next we need the annual interest rate R.
Okay.
And we need the time T measured in years.
Great. Let's look at some example with numbers.
Okay.
Let's say principal P was $200, interest rate R was 10%, and T is 3 years.
Okay.
Let's try to calculate interest only after 1 year and see what happens.
Sure. We're basically going to take all our numbers and plug them into the simple interest formula. So our principal P is $200, our annual interest rate R as a decimal is 0.10, and our time T is going to equal to 1 year. If we multiply those 3 things together, we get $20.
Okay. How about for the second year?
The calculation would be exactly the same. Wouldn't it just be $20 again?
Why do you think we have to use T is equal to 1 again?
Because it was only for 1 year.
Okay, makes sense. And how about the third year?
It's going to be $20 again, Jay, right? Because the third year is just 1 more year tacked on to the end.
Okay, great. So after 3 years, we'll earn $60 in interest. So at the end, we'll have $260.
Isn't that just future value, Jay?
Yeah, future value is just principal plus interest. Principal of $200 that we started with, and $60 of interest that we made, so we'll have $260 at the end.
Seems like we could have just used the future value for simple interest formula. Why did we go through this whole process?
We're getting to the important part now.
Ooh, I can't wait. What's the important part?
Notice the bars that we have? You know how bars are of the same size?
Oh yeah, I see that we have 3 gold bars, and all 3 of those are the same size. We also have 3 red bars, and those 3 red bars are all the same size too.
Exactly, that's the important part I was talking about. In simple interest, the principal remains the same throughout the investment. In compound interest, the principal changes.
The principal changes? How?
Well, the new principal is old principal plus interest.
I'm not sure I understand. Maybe we can redo this example using compound interest instead of simple interest.
Okay, well, first year, everything stays the same. Our principal is still $200, and we calculate our interest by taking 10% of our principal of 200. That's 200 times 0.1 times 1, because it was still 1 year. Our interest is $20.
Okay, nothing new in year 1. Our interest was still $20, just like before.
Year 2 is where things get interesting. Here, our new principal is $220.
In the simple interest case, the principal in year 2 was just $200.
Yeah, but in compound interest, the new principal is old principal plus interest you just earned. This is what we mean by compounding.
So when we calculate the interest in year 2, we have P equal to $220 instead of $200.
Yep, so to calculate the interest, 10% of 220, so 220 times 0.1 times 1 is equal to $22.
It seems like we earn more interest in year 2 than in year 1.
How tall is the second bar, including the both gold part and the red part?
Well, the principal was $220, plus the $22 in interest we earn, we get a total of $242.
Exactly. This is what our principal is going to be for year 3.
So when we calculate the interest in year 3, we have P equal to $242 instead of $200 or even $220. Exactly.
So 10% of $242 is 242 times 0.1 times 1, which is $24.20.
Wow, that was pretty amazing.
Yeah, isn't it? So what's the future value of our compound interest investment?
Well, we started off with a principal of $200, and the first year we earned $20 in interest, just like before.
Exactly, and then second year we made a little bit more, $22 in interest.
And the third year we earned $24 in interest, $24.20 in interest, giving us a total of $264.20.
I know, and it gets even better.
It does?
Right. You notice how the bars grew every time we compound?
Yes. I can see that the gold bars are getting taller and taller because our principal keeps increasing. Because our principal is bigger, each time we earn more interest, so I can see that those red interest bars are also increasing.
Right, and this is when we compound only once a year.
Man, if we could compound more than once a year, we'd be rich.
Actually, you can compound more than once a year.
We can?
Right, we're going to let the letter N represent how many times we can compound in 1 year.
Okay.
So for example, if we compound every month, N is going to be 12 because there are 12 months in a year.
Okay.
What do you think our N is going to be if we compound weekly?
Well, there's 52 weeks in a year, right?
Okay.
So if there's 52 weeks in a year, our N should equal to 52.
Exactly. And how about the number of total compounding throughout our investment?
It seems to me that we should multiply N, the number of times you compound per year, times the number of years T. So N times T?
Okay, sounds good. So what will be the number of total compounding if we compounded weekly for 3 years?
So you are saying if we compounded weekly over 3 years, then N is equal to 52 and T is equal to 3, and we'd compound N times T, which is equal to 52 times 3, giving us a total of 156 times. This means we have 156 bars? We're gonna be rich! Compounding really is the 8th wonder of the world.
Well, not so fast. Even though we have 156 bars, each bar won't be as tall as our previous example.
It won't?
Right. Previous example, our compounding period was 1 year.
Right.
So each compound, we earn years worth of interest.
What about in the weekly case?
Well, because it's compounded every week, each compound, we only earn weeks worth of interest.
Oh, I see. In the weekly case, we earn interest at a much shorter time than in the yearly case.
Right. That's why our red bar is much shorter than our previous example.
Man, doing 156 calculations just to figure out how much money we'll have after 3 years, that sounds terrible, dude.
Well, how much you're going to have after 3 years is called the future value, and fortunately, we had the formula for that. Future value of compound interest formula. Future value is P times 1 plus R over N to the NT power, where P is the principal, R is annual interest rate, T is time in years, and N is number of times you compound a year.
Using the formula seems much easier than doing 156 calculations. Why don't we lead our viewers through an example where we calculate the amount we'll have after 3 years compounded weekly?
Okay. P is 200 in our case, our interest rate is 10%, so 0.10. T is 3 for 3 years, and N is 52 because it's compounded weekly. So our formula says future value is 200 times 1 plus 0.10 over 52 to the 52 times 3 power.
Do I have to put parentheses around the exponent 52 times 3?
Yes, otherwise the calculator would think the exponent is just 52 because of the order of operation.
Okay, hit enter. I'm curious to see what we get.
And we get $269.89. What's wrong? You look disappointed.
Well, when we saw that we were going to have 156 bars, I thought we were going to be rich. But in the simple interest case, we earned $260. In the compound interest case, we earned $268.89.
Okay.
That's just a difference of like $9.
I know, that's only like 2 fancy kombucha for you.
I know.
Well, the thing about compound interest is that to truly see the benefit of compound interest, you need to have a long period of time.
Oh, okay.
You say you're going to retire in 20 years, right?
That's right.
Okay, let's compare simple interest and compound interest for 20 years.
Okay, maybe I'll lead the viewers through the simple interest case first.
Okay.
We want to use our future value for simple interest formula with principal P equal to $200, interest rate R equal to 0.10, and time T equal to 20 years. Substituting these into our future value for simple interest formula, we get 200 parentheses 1 plus 0.10 times 20 close parentheses. We get a total of $600. Jay, why don't you lead us through the compound interest situation?
Okay, compound interest, principal is $200, interest rate is also 10%, T is 20 years, and N is 52. Plug that into our future value for compound interest formula. We get 200 times 1 plus 0.1 over 52, 52 times 20th power, and as a result, we get $1,474.98.
Wow, that's more than twice as much.
Exactly.
Wow, that's pretty amazing. How long have you been saving for your retirement?
20 years.
And you're going to retire when I retire, right?
Yeah, so another 20 years of working.
So for you, you'll have 20 years from before, plus another 20 years. That's going to give you a total of 40 years of compounding. Why don't you lead us through this T equal to 40 example, Jay?
Okay. There's future value for compound interest for 40 years. P is equal to $200, R is 0.10, T is 40 because it's 40 years, N is 52. Plug those numbers into the formula, we get 200 times 1 plus 0.10 over 52 to the 52 times 40 power. And as a result, you get whopping $10,877.77.
What? Your $200 became $10,877.77. That's a lot of kombucha.
Exactly. Imagine you put away $200 every month, starting at age 21.
Oh my God, you'd be rich, rich, rich. I mean, I'd be able to afford to get seasons tickets to the Dodgers and the Lakers.
And Clippers too, right?
Yeah.
The moral of this video is to start saving for your retirement early.
Jay, this looks ridiculous, man. Take this off.
Oh, Roger, what are you doing? Leave that poor but wise man alone.